Okay, this is for Math 8. We are graphing in slope-intercept form, and you need your packet, pencil, and a note card or a straight edge. We're using it for a straight edge. Okay, so we learned the other day about another way to graph the solutions to an equation is when it's written in slope-intercept form. So I want you to write this equation down, y equals mx plus b. The m is your slope, the b is your y-intercept. So steps to graph the equation in slope-intercept form. If it's already written in this format, y is by itself equals something x plus b, which in this case it's a minus 1. So your first step is to identify your slope and your y-intercept. Identify the slope and y-intercept. Okay, step 2 is to, when you plotted this the other day, you plotted the y-intercept first. Plot y-intercept. So in this case, identify the slope and the y-intercept. Our y-intercept is -1. Our slope is 2/3. After you plot the y-intercept, that was a -1, then graph the slope or plot the slope, which is going up 2 over 3. It's a positive, so we know it's going to be going uphill. From here, it's going to go down 2 and to the left 3, okay, and go all the way through your graph. So after you plot your y-intercept, go ahead and, I don't know if I want to say plot your slope, but I'm going to go ahead and say, I'm going to go ahead and put plot your slope. I don't like that word, but we're going to say plot the slope. Then connect your points for a line. So there's your steps. Let's do an example 1. First, identify the slope and the y-intercept. So here's your equation. What's your slope? It's 1/2. Pay attention, that's positive. That's -3. So your y-intercept's -3. Be careful here. They're going up by 1s, going down by 1s, but they're only showing every other by 2s. -3. And their slope is 1/2. That means you're going up 1 to the right 2 because it's a positive slope. I need to go right, so I'll make it positive. Up 1 over 2. So from here, I'm going to go down 1 to left 2. Down 1, left 2. Go all the way through your graph. Take your note card. Don't be lazy. Get a straight edge and make a straight line. Okay, so that graph, again, this line is the solution, represents the solutions to that equation. The other day we had to make a table to find it. Now we can just graph using the slope-intercept form. Okay, so that's what you're going to do for each of these examples. Okay, then back here, apply your slope-intercept graphing. Now we're going to actually apply it to word problems. So here's an example. Ken wants to burn 2,400 calories by going on a brisk walk. The rate that he burns calories is shown by the equation y equals -200x plus 2,400. Graph the situation. Well, let's talk about what this means. So we're going to graph this. So here's our y-intercept, and here's our slope. So our y-intercept, we're starting at 2,400 calories. That's where we're starting. Now he wants to burn the calories. He wants to burn them, so they're a negative. He's doing -200 calories per hour. So for 1 hour, notice this is 1 hour, but notice our increments here. These are going up by 300s. So if we're doing 200 in an hour, then let's say 2 hours, that's going to be 400, so that's going to be a little hard to do. Let's say in 4 hours. Okay, so if we're going, you kind of estimate here a little bit, but let's say if we do 6 hours, that he would burn 1,200 calories, so it's 6 hours, he's going to be at 1,200. So this is a little bit tougher with this graph. So it's 200 per hour, so that means 400 per 2 hours, so it's maybe about there. In 4 hours, that's going to be about 800 that is lost. So it's probably going to be about there. 6 hours, 6 times 200 is 1200. So that's going to be there for sure. Then we can keep going. Let's figure out how many hours is it going to take him to lose all 2,400 calories. Well, what times 2 gives us 24? That's going to be 12. Okay, so then be careful here. You're going to graph this. So that line should be about like that. Do not put arrows at the end of these lines because you're going to go into negative calories. And then here you're going to go into negative time. So don't put arrows. Now, this question. After how many hours of walking will Ken have 600 calories left to burn? So how many hours will he have 600 calories left to burn? So 600 calories is right here. Watch this. It's going to be 9 hours. So this is going to be 9 hours. After how many hours will he reach his goal that he wants to burn all 2,400? It's going to take him 12 hours of walking. Now, that's without having any more intake of calories. So no eating, just walking for 12 hours. Not something that I'd want to do. 12 hours he'll reach his goal. To reach goal. Okay, now, suppose Ken decides that instead of walking, he will jog. That jogging burns 600 calories per hour. How do you think this would change the graph? Okay, well, let's try it. Well, if he's starting at 2,400 and he burns 600, so our new equation is this. If he burns 600, all right, this is kind of nice. It's a little better increments. So he burns 600 in 1 hour. 2 hours, that means he's going to burn 1,200. 3 hours, he's going to burn 1,800. And at 4 hours, he's going to... So look what's going to happen here. This is that second equation. That's this one. So will Ken have to exercise more or less to meet his goal? Well, I would say in time, he only has to work 4 hours. He only has to, if he's going to jog instead, he can jog. It's going to take him only 4 hours. Jogging is going to take less time. Jogging will take 4 hours to reach his goal. So jogging will take 4 hours to reach that goal. Okay? So same thing here. I want you to do that example. Pool membership charges a membership fee and a fee for each visit. So the membership fee is $50. The fee per minute is $3. $3 for each visit. Sorry, not per minute. Ooh, that's be expensive. But $3 per visit. So you want to think about it. It starts at $50 and then $3 for every visit. Now, our X represents the cost of Y for X visits. This is going to be our number of visits, and this is going to be your total cost. Okay, so make sure you label those because those weren't labeled. Now, so let's say if you wanted 50 visits, you're going to have to put in 50 for X, 3 times 50 plus 50. 3 times 50 is 150, plus 50 is 200. So if you want 50 visits, it's going to cost you $200. Okay, how much would 50 cost? How many visits to the pool can a member get for 200? Well, these kind of answer each other's questions. So that one's going to look like this. Take your straight edge. And it's going to look like this. Okay, well, we'll continue working on those type of problems quite a bit. But what I want you to do is I want you to take practice right now in graphing and slope-intercept form and all of these. These two, you might need some help. And I'll work with you guys on that when you get there. And then there's 2 word problems on the back. Here is where you can use the ordered pairs to graph it. Find your slope, find your y-intercept. The relationship, is it proportional or non-proportional? And then the equation, which that'll be interesting to see if you can write the equation from that line. You should be able to see the slope and the y-intercept from there. Then this one, same thing. Here's 2 different scenarios, so you're going to have to read those. So today's a work day on graphing and practicing in slope-intercept form.